In this video, you will gain an overview of stormwater drainage systems. This topic is significant to the construction manager because all developed property will have some type of a stormwater drainage system. The best way to define a stormwater system is that it is some combination of methods and materials which are used to collect and convey rainwater to an off-site point of discharge. There are 5 elements common to stormwater drainage systems. On some sites all 5 are used, but on other sites only some of them might be required. For the balance of this video, we will look at each of these elements. The first is the provision for surface flow of stormwater. And the next is the collection of that water using different types of structures. The third element is the underground piping that connects the structures. And the fourth is the use of detention ponds, which retain some of the water on the site. And finally, the last element is the off-site discharge of the stormwater in either an open flow or by connection to a municipal system. Let's look at the 5 elements in a little more detail with a few illustrations. Initially, rainwater will flow on the surface of the site, such as on a rooftop, a paved area, or a landscaped area. All of these locations will be inclined in some manner to start the water moving by gravity, moving to a lower elevation where it is collected and further directed. One way of both collecting and directing the water is by the use of some type of a ditch. Here are a couple of examples. On the left side we see a concrete lined flume or ditch used to intercept and direct stormwater to prevent erosion on a very hilly site near San Diego, California. And on the right we see an illustration of what is often called a swale, which is simply another name for a shallow ditch. Since most building sites will have paved areas, the collection of stormwater is also integral to the pavement design. Let's look at another example. This is a small office site, and let's look at the left side parking area and understand how this drainage system works and see if we can identify any of the elements used. From the proposed contour lines we can see that the water will flow in the direction of the blue arrows, and when it reaches the lower corner it will pass through a short paved flume which is circled in red here, right here. And once passing through that flume, it will then flow over this area here by my pointer, which is a bed of coarse stone called riprap. The riprap will slow the velocity of the water, allowing it to be released off of the property represented by this brown arrow. So the 2 elements in this simple drainage system are, well, obviously surface flow, and the second component then would be the structure represented by the flume. Our next stormwater element then is the use of structures to collect the stormwater. As mentioned, there are a wide variety of structures, far too many to try to illustrate here. On the left is a grade inlet in plan and actual views. Grade inlets can be placed in both landscaped or paved areas to collect water and direct it into a piping system. On the right we see a type of curb inlet which will collect water from the street pavement and also direct it into the piping system. And the other use for structures is in the discharge of stormwater. Before we discuss discharge structures, look at the upper right picture. This illustrates some reinforced concrete pipe, or RCP as it is called, connecting to a precast structure that will eventually have a large grate placed on the top of the opening. So this structure allows the pipeline to both turn a corner and to collect additional water. The 3 remaining pictures show head walls on the left and apron end walls on the lower right, which are often used at the termination or discharge point of a storm line. These are just a few examples of structures. Let's look at our third element, piping. Because stormwater pipes must be installed at precise gradients for drainage, the various runs of pipe will usually be shown in both plan and profile view to help the contractor. Here we have a run of pipe that totals about 700 foot long. If you haven't viewed the videos on station measurement and profile views, you might find it helpful at this point. Starting at the right, we see outlined in red structure number, the first structure, which is labeled grade inlet number 30. Remember this as we look at this run in plan view in just a minute. we can see that between the first two structures we have 198 lineal feet of 15-inch diameter tongue and groove joint RCP pipe at 0.2% slope, as we see here. Notice how the pipe sizes increase. We're 15-inch here, and then we're 18-inch, and then we turn into 30-inch towards the end of the run. So notice how these increase as we move to the left, since more water is added at each of the additional structures. Remember grade inlet 30 that we saw in the profile? Well, here it is in the upper right, circled in red. And the other lines and structures we just saw follow the path here of these blue arrows. Now let's again follow the blue arrows and visualize that we are rainwater falling on lot 212. This lot will be sloped towards the back, so we will travel by gravity, by surface flow, to the grassed swale. Once in the swale, which is illustrated below here, once in the swale, which has a gradient to it, we will flow to the left and we will enter then grade inlet number 29. We will drop into the top of the inlet. Once in the inlet, which also has a gradient to it, we will then travel through the 15-inch pipe down to grade inlet number 27, and at grade inlet 27 we make a right-hand turn, and now we move from 15-inch pipe into 18-inch pipe. Then we'll cross under the road via inlet number 25 and enter the 30-inch diameter pipe, then through curb inlet number 24 and through grade inlet number 23, and then we'll be discharged into the retention pond. As you think about these graduated pipe sizes, realize that the design engineer must size a stormwater system for the largest possible rainfall event in order to prevent flooding. Often this will be the historical 100-year storm event. In some cases, water volumes are so significant that very large pipes must be used, or even special box culverts. In the upper left, we see, in the upper right, we see backfill being compacted over some larger RCP. While metal and PVC are also used for some storm lines, the advantage of RCP pipe is that it is very strong. This is important as storm piping is often buried very close to the surface, and as such is subject to high loads under roadways and parking areas. Okay, on the upper left we see a large run of 72-inch diameter multi-plate CMP. This pipe is shipped in pieces and must be assembled on the job site. In the lower half of the slide we see two examples of concrete box culverts for very large flows, or even for the diversion of streams under a site. Our next element is the detention pond. Detention or retention ponds are often required and are usually based on storing the volume of the first 1 inch of rainfall on the site. Ponds help to reduce flooding of off-site areas. Here we have 3 pond examples from the Atlanta area. Notice that they all have discharge control structures to prevent overtopping of the pond. Another function of the ponds is to contain oil washed by rain from paved areas such as parking lots, as well as debris and sediment. Let's wrap up with a quick look at our last element, the discharge of the collected stormwater from the site. There are only 2 options. One is the surface discharge of the water, and here we see a residential project in coastal South Carolina. As we learned earlier, water is collected and directed into ponds. In this case, we have 2 initial wet ponds connected by control structures to the 3rd wet pond. Overflow water from the last pond is released by a control structure into the off-site discharge point, in this case, a wetland. Although not illustrated here, the second discharge option is into a municipal stormwater system.